Anyway, let's read that thing that I just picked up. Let's see here. I've got to reach the decontamination room where I'll find Anna. Just hope it's not too late. Okay, so yeah, it was supposed to be that way. Experimental log. Subject Series G3. Experimental subject G301. Control subject B. Kardanev. Was sedated, then deliberately infected. Forced ingestion. Received no antidote. Showed first signs of metamorphosis within 20 minutes. Base phase of metamorphosis complete within 2 hours. Symptoms: increased muscle mass, regeneration of tissue after injury, modification of internal organs, excessive hunger for protein, shutdown of all higher brain functions. Experimental subject G02 or G302. Control subject S. Fratinev. I have no idea. Fratinev? Whatever. No contamination. Received 20 mls or milliliters, something like that, of serum A9. Side effect: mild thoracic skin rash. I see. Experimental subject G303. Test subject G. Petrov. Killed himself by repeatedly bashing his head against the bars of his cell once infected. No data collected. Wow. Experimental subject G304. B. Videlev. Wow, I'm just not getting this stuff. Someone who's Russian, please help me out. These names are getting harder. Subject was sedated and then contaminated by forced ingestion. Received 20 milliliters of serum A9B. Visible mutations after 14 minutes, but did not continue along expected track. Mutation continued in asymmetrical pattern, causing disproportionate development of the upper left limb. The contaminating agent seems to have infected this limb and multiplied within it. Subject's entire body showed great resistance, including exposure to fire. Only left arm showed any signs of vulnerability. Subject destroyed after 15 days of observation. Risk too great. Well, it looks like you made like 3 more of them, so I guess the risk wasn't that great later on. Anyways, experimental subject G305, B. Karian. Subject was injected with 20 milliliters of serum A9, then put down. Subject was infected posthumously, I guess, or posthumously. Yeah. Exocell demonstrated its ability to revivify corpses in otherwise good condition. Serum had no apparent effect. Experimental subject G306, H. Abash. Subject was sedated, then contaminated by forced ingestion. Injections: 10 milliliters of serum A9B and 10 millimeters of A10. A neurotransmitter blocker. Onset of mutation was delayed for 9 hours, 32 minutes. Symptoms were increased muscle mass, aggression, improved regeneration properties, pigmentation, alteration of skin and eyes, reduced higher brain activity, especially cognitive functions. Dissection revealed a tendril along the spinal column, but in a deteriorated form. This could be the breakthrough we're looking for. Interesting. Stupid scientists killing a bunch of random people just to test crap. Is this anything? No. Alright, well, I guess that's it for this room, unless there's something over here. Maybe. Maybe not. Alright then. I fear I might have missed a weapon or something because of that ammo that I keep seeing, which I can't pick up because I don't have the weapon for it. Which is too bad. It looks like they're really big bullets, so it might be like a Magnum or something. Uh-oh. Oh, okay, they're all in there. That's fine. Report about the exocell life cycle. Official report on the exocell life cycle and reproduction. Dr. V. Kamsky and Dr. P. Bakarev. Extracts. There are two main phases to the exocell life cycle: reproduction and contamination. To reproduce, the exocell transforms itself into what we now call breeders, stationary organic structures of potentially considerable size, basically shapeless and particularly repulsive in appearance. When the exocells enter this phase, they find a safe, isolated location, usually high up, attach themselves firmly to it with their tendrils, and immediately start growing. The breeder starts hatching out new contaminators within 24 hours through an asexual budding process. Contaminators are small, fast, and highly mobile. When attacked, they curl up into what could be called a fetal position, exposing a hard external shell, but which is quite soft and vulnerable on the inside. Their mission is to find hosts, infect it parasitically, and feed on the form inside, or from the inside. It may need to repeat the process several times, but eventually this produces an adult mature exocell ready to settle down as a breeder and start producing more contaminators. Physically speaking, contaminators are weak. As a result, they can only contaminate dead, dying, or weakened hosts. Healthy, strong organisms can easily fight them off. This explains why hungry exocells seek to weaken their prey before contaminating it. Once exocell has integrated its hosts, and up to 7 can share single hosts, it effectively takes control of it by sending tendrils up into the host's brain. Thus, to permanently eliminate an infected host, its brain must be destroyed. In fact, the host's other body parts are all but indestructible. Muscle mass increases at a spectacular rate, and bruised or injured tissue heals almost immediately. As Professor Nikolai Kostagnev explained during our last encounter, this process requires large amounts of protein. Human protein is naturally preferred, since it will be building human cells. As a precaution, the contaminators also shut down their host's higher brain functions, essentially switching off the host's personality. The body is left to defend itself and find food. Moreover, it seems that during a more advanced stage of the mutation process, the contaminators reactivate certain of their host's intellectual functions, turning them to their advantage to perceive space, use tools, and even devise and communicate strategies. Wow. One of the main benefits of this is to facilitate the search for new potential hosts by attacking, wounding, and killing other healthy humans. As indicated above, even bodies that are dead but in otherwise good condition can be reanimated by exocells, which energize the host's nervous and muscular system. The tendril in the brain turns the corpse into an extension of the exocell's body in a sort of monstrous symbiosis. Bodies frozen for months or even years could conceivably be used in this fashion by the contaminators. At a certain stage in the mutation, which varies according to individual hosts, the process is reversed. The contaminators escape from the host's body, which enters a state of rapid putrefaction. The same occurs when an exocell is forcibly extracted from a body, usually by destroying the host's brain or by burning it entirely. Whilst We are learning more each day. Our results are already highly promising. Obviously, the next stage is to control the whole process to obtain what we are all striving for. We remain confident. Victor. What are they doing in there? Wow, they're all just like stuck in there. Is this gonna open this door or is it gonna burn them up? I don't know. I'm gonna take out a shotgun just in case. Yeah. That was cool.
The damn thing's stuck.
Too bad.
The damn thing's stuck.
Everything's stuck around here. Oh well. Anything else in here that could be useful? Wow. It's a very odd shadow there. Alright, well, guess that's the last door besides this one and the place I'm supposed to go, I think. I don't see anything else. Yeah, so we have this over here, and well, let's go out this way and see what's over here. Oh, hi there. Whoa. Well, if you're not dead, you're not a problem anymore anyway. Just knocked you straight off. What does this do? Oh, cool. Oh, that's awesome. Oh my. Well, you surprised me. Hopefully you're not the same guy who I just knocked off. Probably not.